All right, let's take a look at SQL and let's take a look at the other information we need for relational databases. So let me share my screen here. Basic SQL commands. I have actually got SQL pulled up here so you can get kind of an idea. Yeah, that's programming. Yeah, it is. It's very, SQL is structured query language, and I believe was invented by IBM. I think they're the first ones that worked with it as a way to make changes in a database. So not just query it, but move this to here, look for duplicates here, that kind of thing. And it's a lot more. I don't know if this is going to give us a good idea, but it's easier to understand because the object ID and it's more human. I guess that's what I should say. You may not think so looking at that, but if you're looking at other languages, you go, oh yeah, that does make more sense. I can see words in there. Top 10 customer ID, right? So SQL is structured query language. Let's get back on task. And it's a computer language that makes relational databases work for you. There are other ways to do it, but SQL is the biggest language out there. For database to function correctly, users need to be able to do 4 general tasks: add new information, access existing information, modify the information that's there, and delete information. And then the easy way to remember this, and it's true, this is how they teach you, it's CRUD: create, read, update, and delete. If we can do those things, then we can do a lot. We can do a ton of stuff. And then what they do is give you some basics, because you're going to get to do this. Like, hey, create table, and this is what it looks like. Alter table, and this is what it looks like. So you get to do a little SQL, which is awesome. That is so cool. Create view. You get to do a little bit of that. It's fantastic. Let's take a look at some relational stuff. That's basic SQL commands. I don't want to read off the table again, because that doesn't really help anybody. All right, so this table summarizes the 4 ways of accessing information. So you can have the direct access. So that database management system gives administrators access to the database, and from there they can write SQL commands to create new databases and existing ones. Query Builder is often what is used. That provides a graphical user interface where people can select what actions they want to perform on the database. So Query Builder is used quite a bit instead of direct access. It takes a little less knowledge to deal with. And then user interface access. Most users won't ever need to interact with the data directly. Instead, they fill out information on a form. A SQL query gets the information and sends it on. A good example of this is, and maybe this hasn't happened to you, maybe you haven't rented a hotel room or not, but you go to a hotel and they have to access like 4 databases. I love to sit there and watch them. It always takes forever. They are accessing these different tables that basically could have been integrated, but haven't yet. And so the person that runs that portion that's sitting there in front of you has to do a lot. And of course, keep you calm while that happens. I've noticed that some places have started switching over to being able to say, okay, let me see what room I'm going to give you. And then it queries the different data systems, brings back the result, says these are the ones. But still, in some places, they'll go into the database, confirm that you are who you are, confirm that you have paid or not paid. And then they go to another database. Now, once they've got that done, now they're going to register you and have you, log in. What's your card? Let's swipe your card in case you spend money or damage the room. And then they go into another data system. And in that data system, they look for rooms that they can give you. And then they finally give you in a room. And so that's why it takes so many of them so long, because those places have not updated their data system. But to get back to what I should have been mentioning, which is that person only really needs user interface access. They're not going to go in and run queries and find out how many people did we have this weekend or anything like that. So that's somebody else's job. And then direct access, that's going to be somebody that's actually like, oh, there's a problem with this. Oh, we need to integrate these databases, these data systems. All right, let's do that, right? And then programmatic addresses. Humans aren't the only ones who need access. Many computer programs need it to do too, so developers can write code into their software that reads and writes, updates and deletes database records through the program. So in other words, you can set up automated flows, is what a lot of people would call those, where it's like, hey, when this happens, trigger this to go over and do that. And then that way the system's automatically changing things. That's used a lot these days. That's just the basics of you know, dealing with, I should talk about normalization and the types of relationships. So let's do that. Let's move on and take a look at a one-to-one relationship within a relational database and move on from there. So here is a one-to-one relationship, student ID, to this other table, this other field in another table called student. And so a one-to-one relationship example would, you know, with this would be, okay, well, let's look up the student ID and then find out who the student is. That's what's happening here. So because these are related, then it can say, okay, well, the student ID is 12 and the person is Jackie, and on in that situation. A one-to-many relationship, which this is a very good example, you have a building and you name it, you number it, whatever you want to do, and then that goes to different tables that have got different classrooms in it, right? So a building has multiple classrooms. And then that way, when you do a one-to-many relationship, right, you've got a building ID in the name, and then you've got the classroom and the building ID, right? So we see 1 and 1, that's in the art building. 2 right there is in the science building, and 3 is in the math building. So you end up having a one-to-many relationship so that you can better store the data in the tables it needs and be able to request the data that you need and have it pull that out of those different tables, which is fantastic. And then many-to-many. In that situation, if you take a look at what's going on in the database design example, you've got a teacher ID, a teacher, and a student. You got a student ID, a student, and a teacher. So if we want to, we can say the teacher ID is linked to teachers, the students is linked to the, teacher, yeah, the teacher ID will link to teachers. This will be the teacher's name. And then the student ID is linked to student, but the students will also be linked to Jackie, TO, and the student column. So it's fantastic. And this is a good idea of what you sometimes need. Oh, I was going to highlight that. Sometimes need in a table, or almost always, which is a junction table. In other words, I've got a table here and a table there, and I'm going to link them through another one. And this is all pretty basic information, and I know I'm shooting it at you, but you're going to dig into this a little deeper, and please ask questions as you go along. And if you need other examples, ask me and I will give you more examples of how this works. But they do a real clear job of it in their system here, which is fantastic. The last thing I want to mention is normalization, and that's a video there. Normalization really involves trying to make sure all the data is good. So normalization is a term that we would use to say, well, what would happen if we ended up with 2 James McBrides, and we actually have 2 table entries for the exact same person. So it is James McBride and it is James McBride, the same one that is on your screen now. And we shouldn't have that. Normalization is the process of saying, let's go through and clean out the database systems and look for these duplicates that may exist. And that's normalizing the database. Of course, that can be dangerous as well, because you need to make sure you're looking for everything when you're doing that kind of thing. So you don't leave some little piece of information out there. And some other table where, you know, James McBride has this office. And so there's still 2 entries for that out there someplace. So it's more complex, but that's really the basic idea of what you're trying to do, is say, let's make sure that we've only got one set of data for that particular record, and we don't have multiple records for the same thing.